Hi everyone. Today we're going to study measures of central tendency for ungrouped data. Let us define measures of central tendency. A measure of central tendency is a single value that attempts to describe a set of data by identifying the central position within that set of data. There are three most widely used measures. The first is the mean, next is the median, third is the mode. Let us discuss the measures one by one. The mean, symbolized by this symbol, and this is read as x bar, is the sum of all terms divided by the number of terms. In symbol, we may write x bar equals sum of observations divided by total number of observations. In formula, we may write sigma x over n. The sigma is read as summation. So the formula here is read as summation of x over n. Let's have an example. The data represent the number of days off per year for a sample of individuals selected from 9 different countries. Find the mean. The values are here: 20, 26, 40, 36, 23, 42, 35, 24, and 30. Using our formula here, we will take the sum of all these numbers. So we have 20 plus 26 plus 40 plus 36 plus 23 plus 42 plus 35 plus 24 plus 30 all over 9, because there are 9 numbers here. Using our calculator, the numerator will be 276 over the same number 9 in the denominator, and simplifying this, we have 30.67, and this is rounded to 2 decimal places. This is our final answer. On the topic about mean, there is what we call weighted mean. When the data is given with frequencies, the mean can be calculated by multiplying each distinct value by its frequency and then dividing the sum by the total number of frequencies. In symbol, we may write x bar equals the summation of fx all over summation of f. Let us see how the formula will be used. Let's have an example. Find the mean for the following distribution. We have a table here with 2 columns. The first column is for the marks. We regard that to be x. The second column is the frequency with the symbol f. In the first line, we can see that the mark 45 has a frequency of 4, 30 with 1, 85 with 3, 90 with 5, 75 with 3 respectively. Next, we're going to take the summation of the frequency, and that is equal to 16. The next step, we need another column that says fx. This is the column of the product of the mark and the frequency respectively. It means to say we're going to multiply the 45 with 4. We will put the answer here, so on and so forth. So the first blank will be 180. 30 times 1 is 30. 85 times 3 is 255. 90 times 5 is 450. 75 times 3 is 225. And then at the bottom, let us take the summation, and that is equal to 1140. So this values summation of this column, also of this column, are the ones needed for our formula. So we have x bar equals the summation of fx is 1140, and it is now written here, over the summation of f is 16. Then simplifying, getting the quotient, we have 71.25. This is our final answer. Let's have the second measure, and this is the median. In books, we can see the symbol as capital M, D, N for the median. As defined, median is the middle value that divides the ordered data from smallest to largest into 2. We're going to use this formula, MDN equals n plus 1 over 2. But take note that this formula will only describe the position of the median. If n is an odd number, the median is the middle value of the ordered data from smallest to largest. If n is an even number, the median is equal to the two middle values added together and divided by 2 after the data has been ordered. Let us see some examples. Example 1. Find the median of these values: 684, 764, 656, 702, 856, 1133, and the last is 1132. First thing to do is to arrange the data from smallest to largest. So the first value will be 656, next is 684, followed by 702, next is 764, next is 856, then 1132, and the last 1133. Take note that n, or the number of data, equals 7, and this 7 is an odd number. Let us now use our formula here. So median equals, the n plus 1 is now 7 plus 1, taken from here, the number 7, over 2. Simplifying this, 7 plus 1 is 8 divided by 2, and this is equal to 4. This number 4 here describes the fourth value of our arranged data. So finding the fourth value, this is the first, second, third, and the fourth. The 764, that is the median. This is our final answer. Let us have example 2. The number of guest rooms of 10 hotels in Muscat are 71, 30, 61, 59, 31, 41, 47, 64, 23, and 22 respectively. Find the median. First, let us arrange the data from smallest to largest. So we have 22 as the first term, followed by 23, next 30, then 31, followed by 41, next is 47, and then 59, then 61, followed by 64, and the last is 71. Take note that our n equals 10, and this is an even number. Using our formula now, we will write median equals 10 plus 1 over 2. And 10 plus 1 is 11 divided by 2, and this is equal to 5.5. And this is the 5.5 value of the ordered data. Take note that this is between 5 and 6. So we identify the 5th and the 6th values respectively, 41 and 47. What we're going to do is to get the sum of these two values and divide by 2. So we have 41 plus 47 over 2. This is equal to 88 over 2, and the answer is 44. This is our median. Take note, the median 44 divides the ordered data into two groups. The first group is below the median, and the other group is above median. This is our final answer. Let's go now to the third measure, and that is the mode. Some books give the symbol MO for the mode, and this is defined as the value that appears most frequent in the data set. A distribution with only one mode is said to be unimodal, while with two modes is bimodal, three modes is trimodal, and so on. Let's have example 1. Find the mode for the following data. Let us simply observe which value appears most frequent. We can observe that this 120 appears 3 times. There is another value, this 110, appears 2 times, while others appears only once. In this distribution, the mode is 120. This is our final answer. Let us have example 2. Find the mode for the following data: 110, 131, 103, 184, 112, 197, 113, and 122. We can see that each value appears once. In this case, we will write there is no mode. Take note, do not write mode equals 0, because this 0 is a value that may be part of any data. So this no mode is our final answer. Let us now study mid-range. This mid-range is another measure of central tendency. Let us now define mid-range. The mid-range, denoted by MR, is defined as the sum of the lowest and highest values in the data set divided by 2. In symbol, the mid-range or MR equals lowest value plus highest value all over 2. For example, find mid-range of the following data: 12, 13, 46, 38, 24, and 21. We can see here that 12 is the lowest value, while 46 is the highest. Computing for the mid-range, this is now equal to 12 plus 46 all over 2. 12 plus 46 is 58, and divided by 2, the quotient is 29. This is the mid-range. This is the final answer. Today we're going to study mean for group data, and this is under measures of central tendency. The formula of the mean for group data is given here, and this is x bar equals sigma f x sub m all over n, where x bar is the mean. The sigma symbol is read as summation. X sub m is the class midpoint. F is the frequency, and the n is the total number of cases. So this formula will be read as x bar equals summation of f times x sub m all over n. Let us see examples how this formula is used. Let's have example 1. Find the arithmetic mean for the following distribution. We have a table here with 2 columns. The first column is the class intervals, and we have 5 intervals here. And the next column is the frequency for the corresponding class intervals. See the first class interval as 5 to 10, and the frequency is 3. The second group is from 10 to 15 with frequency 1. Third group from 15 to 20 with frequency 5. Fourth group from 20 to 25 with frequency 3. The fifth group is from 25 to 30 with frequency 8. The next step that we will do is to compute for the n, the total number of cases, where we will take the sum of all the frequencies, and this is equal to 20. After that, we need another column for the class midpoint, and that is the x sub m. The formula for the class midpoint is given here, and this is lower limit plus upper limit over 2. The lower limit and upper limit are the end numbers of corresponding class interval. So in our first class from 5 to 10, the lower limit is 5 and the upper limit is 10. Getting the midpoint of this group, we have now this 5 plus 10 divided by 2. Simplifying, this 5 plus 10 will give 15, and then this is divided by 2, and we will have 7.5. And this value we will write on the blank. So we have here the 7.5. We will follow this idea for the other blanks on the class midpoint column. So you see, this 12.5 comes when we add 10 and 15 divided by 2. This 17.5 comes when we add 15 and 20 and then divide by 2. The 22.5 comes when we add 20 and 25, then divide by 2. The 27.5 here comes from 25 plus 30 divided by 2. So we are now complete with a column for class midpoint. And then we need another column for f times x sub m. It means for the first blank here, we're going to multiply this number 3 and 7.5. That is the frequency and the class midpoint respectively of the first class interval. So we have here 22.5. For the other blanks here, we will follow the same idea. So 1 times 12.5 is 12.5. 5 times 17.5 is 87.5. 3 times 22.5 is 67.5. And 8 times 27.5 is 220. So we are done with all the blanks in this column. The next step is we're going to take the summation, or we say we will add all these numbers and we will put the sum here. And that is the summation of f times x sub m. And the value is 410. Now, we are ready to use our formula for the mean. X bar equals the summation of f times x sub m all over n. So these values we will collect from our table. And this value will be our numerator, that is the 410, and the n is coming from the summation of the frequency. So we have 410 divided by 20, and that is 20.5. This is the mean. This is our final answer. Let us have example 2. Find the arithmetic mean for the following distribution. We have 5 class intervals here with their corresponding frequency. So let us solve for the mean. Step 1 is let us collect the n, and that is taking the total of this column, and this is equal to 30. Next, we need the class midpoint for each of the classes. We will use our formula x sub m equals lower limit plus upper limit divided by 2. So for our first blank here, we will use this one, the lower limit, plus the 9, that is the upper limit, then divided by 2. Simplifying further, 1 plus 9 is 10, divide by 2, and this is equal to 5. This number 5 we will put on the blank here. Let us follow the same idea with the other blanks. So you see, this number 14 comes when we have this 10 plus 18, then divided by 2. This number 23 comes from 19 plus 27 divided by 2. This 32 comes from 28 plus 36 divided by 2. This 41 comes when we add 37 and 45, and the sum is divided by 2. Next, another column for the f times x sub m. Again, we will multiply the frequency and the class midpoint of each class interval. So for the first blank, this is 4 times 5. We will have 20. That idea we will follow on the other blanks. 7 times 14 gives 98. 10 times 23 gives 230. 6 times 32 equals 192. 3 times 41 equals 123. Then, let us take the summation and we will put the answer at the bottom. So we have the summation of f times x sub m equals 663. Now let us use our formula for the mean. X bar equals the summation of f x sub m all over n. Taking the values from our table, we have the numerator as the 663 and the denominator is 30. Simplifying this, the quotient will be 22.1. This is our mean. This is our final answer. Today we're going to study measures of central tendency. In particular, we will study the mode of grouped data. Let us first define the mode. The mode is the value that appears most often. In a grouped distribution, the class with highest frequency is called the modal class. Preference for this measure over the mean and median is usually influenced by the desire to obtain a quick estimate of the average. Let us study now the mode of grouped data. This is the formula. MO equals x sub LB plus the fraction whose numerator is d sub 1 over the denominator, which is the sum of d sub 1 plus d sub 2. And this fraction is multiplied by I. The MO is the mode. The x sub LB is the lower class boundary of the modal class. We can see the d sub 1 in the numerator also as one of the addends of the denominator. D sub 1 is the difference between the frequency of the modal class and the frequency of the preceding class. There is d sub 2 here. D sub 2 is the difference between the frequency of the modal class and the frequency of the succeeding class. And this I is the class width. Let us see this example. Find the mode of the distribution below. We have 1, 2, 3, 4, 5, 6, 7 classes. There is a frequency of 2 for the first class, 1 to 9. There is a frequency of 6 for the class interval from 10 to 18. There is a frequency of 9 for 19 to 27. A frequency of 10 for the class 28 to 36. A frequency of 12 for the class 37 to 45. A frequency of 7 for the class 46 to 54. A frequency of 4 for the class 55 to 63. Let us now write the formula of the mode. For step 1, let us find the modal class. We define this as the class with highest frequency. The highest frequency is 12. So the modal class is that 37 to 45 class. For step 2, let us collect the required values. Starting with the XLB. This is the lower boundary of the model class, and this is equal to 36.5. We got this value from this lower limit, which is 37, minus 0.5. That is why we write here 36.5. Next is the D sub 1. This is the difference of 12 and 10. So 12 minus 10 equals 2. D sub 1 equals 2. For D sub 2, this is 12 minus 7. And this is equal to 5. So D sub 2 equals 5. I is the class width. So this is the number of items in a class. Let's say from number 10 to 18, we will count those numbers inclusive. So we have 9. We can also compute for the class width if we will subtract the adjacent lower limits. Let's say 10 minus 1 gives 9, or 19 minus 10 equals 9. The class width can also derive from the difference of two adjacent upper limits. Let's say this 18 minus 9 is 9, or 36 minus 27 equals 9. Going to step 3, let us substitute the values in the formula, which is this formula, and solve. So we have now the X sub LB is 36.5 plus the D sub 1 is now 2 over D sub 1 plus D sub 2. So we write here 2 plus 5. And then the fraction is multiplied by I and is now substituted by 9. Let us simplify further. The denominator 2 plus 5 becomes 7. Let us multiply the number 2 with the 9. We get 18, and this is divided by 7. So the simplified value is 2.57. The sum of 36.5 and 2.57 is 39.07. This is the mode. The computed mode, and that is the 39.07, is within the modal class and theoretically acknowledged as the value that appears most often. This is our final answer. Today, we're going to study the median of group data for the measures of central tendency. Let us first define the median. The median is the score point which divides a ranked distribution into two equal parts. Thus, 50% of the data lies above the median and the other 50% below it. This is the formula for the median of grouped data. The MDN means median. This XLB is the lower class boundary of the median class. In here, the N is the total number of cases. This CF sub P means cumulative frequency of the class preceding the median class. This F is the frequency of the median class. And the I is the class width. Let us see this example. Find the median of the distribution below. There are 1, 2, 3, 4, 5, 6, 7. 7 classes in our example. In the first class interval from 1 to 9, there is a frequency of 2. 6 frequency for the class interval 10 to 18. Frequency of 9 for the class interval 19 to 27. Frequency of 10 for the class interval 28 to 36. Frequency of 12 for the class interval 37 to 45. Frequency of 7 for the class interval 46 to 54. Frequency of 4 for the class interval 55 to 63. First thing that we should do is to get the total of the frequency, and that is our N. It is equal to 50. Next, let us compute for the class width. We write here I equals 9. The class width equals 9. We can compute for the class width by comparing the adjacent lower limits. See this 10 and the 1. 10 minus 1 gives 9. Or 19 minus 10 equals 9. The same is true with 55 minus 46 equals 9. We can also compute for the class width by getting the difference of adjacent upper limits, like this 18 minus 9 equals 9, or 45 minus 36 equals 9. We need a column for the cumulative frequency, that is the CF. And the values for this column are here. This number 2 is copied from the frequency of the first class. Then 2 plus 6 equals 8. So we write here 8. 8 plus 9 is 17. 17 plus 10 equals 27. 27 plus 12 equals 39. 39 plus 7 equals 46. And 46 plus 4 equals 50. The cumulative frequency of the last class must be equal to the total number of frequency. Let us now write the formula of the median. For our step 1, let us find the median class. Or we say that we look for the n over 2 item. Or we say the middle term. Let us compute for the n over 2. Our n is 50 divide by 2, we have 25. We are looking now for the middle term, that is the 25th item. In this case, the 25th item belongs to the median class. For step 2, locate the resulting item in the CF column. It means the cumulative frequency column, and that is the median class. This is the CF column. The 25th item is found in here. It means to say that 28 up to 36 is our median class. For step 3, let us collect the required values of our formula. A while ago, we have the n over 2 value, and that is 25. We computed this from step 1. Next, the x sub LB equals 27.5. We got this value from this 28 minus 0.5. Next is the CF sub B. This is the cumulative frequency of the preceding class. This is the median class. And this is the CF of the preceding class. So 17 is the value here. F is the frequency of the median class. This is the median class, this is the F. So the value is 10. Class width is the 9 that we computed from the beginning. So we write it here. Now, let us substitute the values in our formula. So we have now 27.5 plus 25 minus 17 all over 10, and this quantity is multiplied to 9. Let us simplify this 25 minus 17. We have 8. Simplifying this 8 over 10 gives 0.8. The product of 0.8 and the 9 is 7.2. And we take the sum of 27.5 and the 7.2, the median is 34.7. We say that half, or 25, of the respondents scored below 34.7, while the other half, or the other 25 of respondents, scored above it. This is our final answer. Today we're going to study coefficient of skewness. Let us define skewness. Skewness is a measure of symmetry, or more precisely, the lack of symmetry of the graph of the distribution. A distribution or data set is symmetric if it looks the same to the left and right of the center point. Here are the distribution shapes. Any distribution will fall in either of the three shapes here. In the middle is the normal distribution, and this curve is what we call the normal curve. The normal curve represents a perfectly symmetrical distribution, or we say that there is no skew in a normal curve. In here, the mean is equal to the median and is equal to the mode, and they are located at the center of the distribution. On the left side is what we call negatively skewed. This is the graph. In negatively skewed, the mean is less than the median and the median is less than the mode. Now, with respect to the tail of the graph, it is going to a negative direction, and we say that the graph is skewed to the left. Let's go now to the right side curved, and this is the positively skewed graph. This is the graph. In this graph, the mode is less than the median and the median is less than the mean. With respect to the tail of the graph, it is going to the positive direction. And we say also that this graph is skewed to the right. Let us now discuss coefficient of skewness. A measure to determine the skewness of a distribution is called coefficient of skewness. The formula is here. Sk, that is the skewness, equals the fraction, whose numerator is 3 times the difference of mean minus median over the denominator, which is the standard deviation. In our values, we expect the range of skewness to be from -3 to +3. If skewness is 0, then the distribution is normal. If skewness is positive, then the distribution is positively skewed. With respect to this formula, skewness will be positive if the mean is greater than the median. If skewness is negative, then the distribution is negatively skewed. With respect to this formula, skewness will be negative if the median is more than the mean. Again, here are the distribution shapes where the middle is the normal when skewness is 0. When skewness is positive, we expect a graph that looks like this, while when skewness is negative, the graph is like this. Let us see this example. Find coefficient of skewness for the distribution with mean equals 42, median equals 45, and SD or standard deviation equals 4. Describe the shape of the distribution. For our solution, let us write the formula of skewness, and then let us substitute the corresponding values. The mean is 42, the median is 45, and the standard deviation is 4. Simplifying further, 42 minus 45 gives -3. The product of 3 and -3 is -9. And the quotient -9 over 4 is -2.25. This is the skewness. We have a negative value here. So it means we will have a graph that looks like this. This is the negatively skewed graph. We can see here that the mean is on the left of the median. It means the mean is less than the median. With respect to the tail of the graph, the tail is on the left, thus we say that the graph is skewed to the left. This is our final answer. I hope you learned something from this video. See you again next time.